Hello students, welcome to the channel. In this target 750 plus video, we look at quadratic equations. So let's begin. Question 1. In the equation x squared plus kx plus 12 equal to 0, k is a negative integer. If the equation has real and different roots, which of the following is a possible value of k? So we have x squared plus kx plus 12 equal to 0. So the discriminant of this equation should be greater than 0 because the equation has real and different roots, right? So for real distinct roots, the discriminant is positive. So b squared minus 4ac is positive. So k squared minus 4 times 1 times 12 is positive, or k squared minus 48 is positive. So k squared is greater than 48. So I need to choose a value of k such that its square is greater than 48. Now it can't be a because minus 2 square is 4. It can't be b because minus 4 square is 16. Can't be c because minus 6 square is 36. The answer will be d because minus 8 square is 64, which is greater than 48. So the value of k is minus 8. Question 2. If the number a is a solution to both x square minus 3x plus 2 equal to 0 and x square minus x minus 2 equal to 0, what is the value of a? Okay, so x square minus 3x plus 2 is 0. So I can split the middle term and write x square minus 2x minus x plus 2 is 0. So x common, x minus 2 minus x minus 2 is 0. So x minus 2 times x minus 1 is 0. So x could be 2 or 1, right? Here we have x square minus x minus 2 equal to 0. So again, I split the middle term and I write x square minus 2x plus x minus 2 is 0. So x times x minus 2 plus x minus 2 is 0. So x minus 2 times x plus 1 is 0. So x is 2 or negative 1. So now we have a number a, which is a solution to both equations. So we find that the common solution is 2. So the value of a should be 2, option D. If 4 is one solution of the equation x squared plus 3x plus k equal to 10, where k is a constant, what is the other solution? Okay, so let's first find the value of k by plugging 4 into this equation. So 4 squared plus 3 times 4 plus k is 10. So 16 plus 12 plus k is 10. So 28 plus k is 10. So k is minus 18. Right? 10 minus 28. So the equation then becomes, I'll write here, x squared plus 3x minus 18 minus 10 is 0. So x squared plus 3x minus 28 is 0. When I split the middle term, I get x squared plus 7x minus 4x minus 28 is 0. So x plus 7 times x minus 4 is 0. So x can be negative 7 or 4. So 4 is one solution. We already know that. The other solution is negative 7. Which of the following sets of x values satisfy this inequality? Okay, so 2x squared plus x is less than 6. So 2x squared plus x minus 6 is less than 0. We split the middle term. 2x squared plus 4x minus 3x minus 6 is less than 0. 2x x plus 2 minus 3x plus 2 is less than 0. So 2x minus 3 times x plus 2 is less than 0. So if I look at the roots of the quadratic, they have 3 by 2, right? And it is at minus 2, right? So the expression becomes 0 at 3/2 and -2. So when the quadratic expression is negative, the value of x will be between these two roots, right? So the expression is negative between the two roots. Greater than 3/2, the expression is positive, and less than -2, again, the expression is positive. So here we are looking at less than 0. So the value of x should lie between -2 and 3/2. So that's option A. For which of the following intervals of k does x equal to k times x minus 1 times x minus 2 have real roots? Okay, so x is given as k times x minus 1 times x minus 2. So let's first convert this to standard quadratic form. So x is k times x square minus 3x plus 2, which is kx square minus 3kx plus 2k. So I get kx square minus 3kx minus x plus 2k is 0. So kx squared minus x times 3k plus 1 plus 2k is 0, right? So now I have it in the form of ax squared plus bx plus c is 0, right? Now, for this to have real roots, the discriminant, which is b squared minus 4ac, the discriminant should be positive. So b square would be minus of 3k plus 1 whole square minus 4 times a is k and c is 2k, right? This should be positive. So the minus squared will cancel because minus into minus would be plus. So 3k plus 1 whole squared would be 9k squared plus 6k plus 1 minus 8k squared should be positive. So k squared plus 6k plus 1 is positive. Now here we get a quadratic in k, and that expression should be positive. So again, we'll have to find the possible roots of this quadratic. So let me solve here. So I'll use the discriminant formula. So k will be minus b plus minus under root of b square minus 4ac by 2a. So that will be minus 6 plus minus 36 minus 4 divided by 2. So minus 6 plus minus root 32 by 2. So minus 6 plus minus root 32 is 16 into 2. So 4 root 2 divided by 2. So that would be k is minus 3 plus minus 2 root 2, right? So what will be the two values of k? K can be minus 3 plus 2 root 2 or minus 3 minus 2 root 2. So root 2 is 1.4. So 2 root 2 is 2.8. So minus 3 plus 2.8 will be negative 0.2. And minus 3 minus 2.8 would be negative 5.8. So if I showcase the roots as minus 5.8 and minus 0.2, then the expression k square plus 6k plus 1 will be negative between the roots. Greater than minus 0.2, it would be positive, and less than minus 5.8, it's again positive, right? So which interval from the options? If k is less than negative 6, then it is in this region, right? So it will be positive. So this is a good option. If k is less than negative 2, so negative 2 will be here somewhere, right? So less than negative 2 is not a certain option because there is a region in which this expression is negative. So it can't be B. If k is less than 1, okay, so 1 is somewhere here. So again, that has the region that includes the less than 0. So this is not good. And similarly, k less than 2 is not good as well. So the best answer is option A. Okay, so that was a quick drill on advanced problems from quadratic equations. Hope this exercise helped. If it did, hit like and subscribe to the channel. I'll see you guys in a new video soon. Take care. Bye-bye.